All right. Good morning, good afternoon, and good evening to everybody, wherever you are. Welcome to another one of the WISE webinar series. And today, I'm actually kind of geeking out on this one too. We get to unpack the whole idea, the whole concept, and really kind of tie into what the heck this zero trust thing is. And for me, I'm actually looking forward to this because having come out from the security industry and really understanding what I think I want out of it, and having seen, unfortunately, how the technology, the ideas and the concepts have been kind of morphed a little bit by the security world, by the marketing side of the folks and some of the other areas, I kind of really want to unpack and get back to the basics to what we actually really consider to be a zero trust idea and a concept, and some ways we can actually implement it. So without further ado, I'm going to shut up and I'm going to let my esteemed colleagues and guests introduce themselves. So I'm going to go left to right on my screen. So John, if you don't mind, sir, you're up first.
Hey, John Kindervag. I'm Senior Vice President at Ontoit, a managed service provider, a zero trust managed service. So we're doing zero trust managed services. And I just joined a month ago. Before that, I was 4 years at Palo Alto Networks as a field CTO. And then before that, 8.5 years at Forrester Research. And that's where I created zero trust. So I'm the guy who created it. So if you hate it, you can blame me. If you like it, then you can thank me, I guess. So.
I think we can thank you for the idea and the concept, and I think we need to go find somebody to taser to see what the hell they warped it into, to be perfectly honest. We'll figure that one out. I want a hit list. At the end of this, I want a hit list. Devin, sir, you're up.
Awesome. Thank you so much, Chris. Yeah, Devin Breen, co-founder of CHAaSM. We struggle to reinvent ourselves every day, I think, like a lot of companies. So our mission changes. We used to say we were trying to solve systemic coding bad practices, but one of the things that I've thought about more lately is how do we inject quality at the earliest stages of the software build process. And so we've started talking, as we know today, zero trust has become a massive buzzword. And so one of the things that we've been doing to differentiate ourselves is talking about trusting nothing. So excited for the discussion today.
We got to unpack the heck out of this one. This one I'm looking forward to. All right, and then on my, hang on, where am I? I will apologize in advance, by the way. I'm on 2.5 hours of sleep because some interesting folks in Israel had me on a webinar this morning, ironically enough, talking about some of this stuff in a fintech webinar. It was an entire week's worth of fintech webinar, and we had one discussion on security. So you can imagine how fun and scared everybody was. All right, so to my right, I've got Keys, and he's put his video on, which he doesn't normally do, so much appreciated. All right, you're up, sir.
Yeah, so I'm Keys, I go by an alias. I am the CTO and co-founder of EthoPass. We have built and invented a dynamic key authentication solution. We are trying to remove the first factor, trying to remove the username and password from the Internet of Things, if you will.
All right, appreciated. As always, I'm watching the questions, so everybody that's on here, please feel free to say hi. Please chuck a bunch of questions up. I will be going backwards and forwards on them. But first and foremost, let's actually go back to the genesis of this, and I'm going to throw this at John. What I would love to know, when you first started and you first really said, okay, how do we do this? What is this? Give me, as best as you can, in a minute or so, the thought process on zero trust, please. Where were you wanting to take this? Let's go back to the basics.
So if you go back to the turn of the century installing firewalls, there was a trust level that you had to define in policy based upon the interface. So the internal interface was a high trust value, 100. The low trust value was the external network, and you had to arbitrarily define a trust value in order to create policy, not based upon the traffic, but just on the interface. And I thought this was the stupidest thing I'd ever seen, this thing of trust. And then I started investigating trust and what it was and looking at it. And then I got over to Forrester, and I was asked to look at what are the fundamental problems of cybersecurity. And I remember talking to a guy, and he said, well, we do trust but verify as our strategy. And I said, well, why do you do that? Well, Ronald Reagan says we should. I'm like, well, Ronald Reagan, the great cybersecurity expert. Well, we didn't call it cybersecurity, right? What's a cyber? Why are we securing a cyber? I mean, we even in our own terminology. It was InfoSec, which was a better term. So
Yeah.
so I started to look, what did Ronald Reagan actually say? And he never said trust but verify. He said a Russian term, and I can never pronounce it correctly, but it's dovernai no provernai, which means trust but verify if you translate it word for word. But if you get the essence of it in Russian, it means I'm not going to be trusting you, right? He was talking to Mikhail Gorbachev, talking about this as his proverb. So I realized that trust was a problem because it's a human emotion that's been injected into digital systems for no reason at all. Packets don't have emotions. Electrons and photons don't have emotions. I don't know if any of you guys knew Michael Hamlin. He went by Hacker Joe.
How could you?
Back
Yeah.
Yeah. So he was a really close friend of mine. He was actually driving to Dallas when he was killed in a car wreck. But we used to have these conversations. He was a big mentor of mine, and he would talk to me because he was a physicist, and he would talk to me about the physics of a packet, and that really informed it too. So there's a whole lot of things that went into it, and eventually, in 2010, after a couple of years of research and talking to people, I wrote No More Chewy Centers, which was the first thing. So it said, just don't trust any packet, and that will free you up to build real policies and really protect stuff. So that's where it came out of.
And it's morphed. I mean, I love, don't get me wrong, I love the general concept, the idea on what we should
Right.
do. One of the polls I did this morning is I put a poll out to the fintech folks, and I'm like, given the situation, do you trust but verify, verify then trust, verify then maybe trust but check again, pay more to the lawyers, or welcome everybody with open arms? And almost everyone went to trust and verify, and I'm like, all right, we need to have this conversation in way more depth.
Yeah,
Devin,
because trust is just not a thing that exists because it's binary, right? So as soon as I
right.
say, yeah, I don't trust Chris so much, well, then I just don't trust him. There's nothing else there, right? And if you look at the history of that word, it's typically been maybe a religious word or a philosophical word, but suddenly when it becomes in business and technology, it's always a bad thing. So, I use, have I validated Chris? Do I have some degree of confidence that Chris is who Chris is? I mean, even with deep fakes, do I know if this really Chris? I have no idea, but I know Chris is not on the network. And so it's the anthropomorphization of a lot of these human concepts to bring them into the digital world to try to understand technology that's been the problem, right? We say, Devin is on the network or Keys is on the network, but they're not. You're sitting in, you haven't turned into a subatomic particle and been transferred over the public internet to the Citrix GoToWebinar server. It hasn't happened. And so, maybe it happened in Tron or Lawnmower Man, but we
We're
shouldn't
working
learn
on
about.
it. Believe me, I'm working on the EG monitors. I'm getting there. But again, you look at where we're heading in that direction, and we're getting, I mean, it's even crazier for us. And the
Right.
stuff we're looking at it is, okay, John, can I validate who you are at Devin or Keys? But then how can I continue to understand who you are? How can I continue to understand that? What variables to pull in? Situational awareness, military,
Right,
from that
right. Well, I
situation.
mean, and that's something to talk about when you with Keys or whatever related to identity, because I suppose you're focusing on identity issues. And we haven't even got, I'm sorry, I'm taking it in another direction, but the entropy of identity is something
Yeah,
that it doesn't exist in human terms other than maybe, if I grow my beard long like yours, then there's some identity entropy. You don't look like your photo on this thing, right?
right.
So, but in
Yeah,
human terms, we don't really have that. We have aging, but not entropy. So,
yeah. It's interesting. Devin, sir, give me some thoughts on this as well, please. I'd love to know where you are, where you're taking it. And Keys, same thing.
It's interesting. The space is so complex, and I think that's part of the problem for understanding is that the basis, right, that foundational knowledge for a lot of folks doesn't really exist. So I haven't tried to tackle every single area of cybersecurity because I just don't have the time. But as I grow, right, and as we learn more, there's more areas that we can kind of attach this framework to. But I focused very much on the development environment for the last 2 years and just thinking about trust in the development environment. We had been talking about source code supply chain control for 2 years, and then SolarWinds happened, and everybody finally understands what we're talking about. It's interesting when the market conditions kind of rise to meet your mission. So is that great for us as a business if we solve that? Yes. It's not good for the community, and we need to educate folks. The problem is I'm finding, and I'm sure you guys have seen this too, right? As a commercial company, how do you build trust with those customers who are having those problems to actually get into the environment and have them make wholesale change? Because, I think of the current state of cybersecurity a lot like bloodletting. It was like it was something that doctors did for 3,000 years. And, when we think about the pace of innovation and development, there's 100 billion new lines of code going to be created this year. So we're moving, we've done 3,000 years of development, right? In terms of, the acceleration of AI and innovation. It's time for some wholesale, hey, maybe there's a better way.
Well, okay, that's an interesting one. Give me that note. Give me some more logic on that number. And the reason I ask is I do a lot of work in the automotive space, and we all know that we've moved a lot from the regular interfaces that we have in automotive systems, where it used to be a very analog architecture, to a ridiculously overly complicated digital architecture we have in there now. Because we've gone from basically the car just giving me information about what it's doing to all of the surroundings, and it's making decisions, or potentially making decisions on my behalf. I mean, I remember years ago, I picked up a relatively new car, Mercedes, and somebody told me I had like 100 million lines of code in this stupid thing. And I'm like, hang on, every 70 to 100 lines, or is it 700 to 1,000 lines, there's 100 bugs in this amount of, and I'm like, freaking bugs is in this damn code. And then you start taking a step back and going, well, okay, whose hands were on this code? How much did you actually write versus how much did you beg, steal, and borrow from the 90 other places you pulled it in from? And is there implicit trust in there? Do you go, oh, I'll just use this, it'll be perfectly okay. And then we end up with another bloody SolarWinds. But now we've got SolarWinds at 100 miles an hour because some of us don't like driving the speed limit between here and Las Vegas, etc. And you got 100 billion lines of code being developed or something stupid this year.
Yeah, I mean, let's just one interesting aside, and then I'll send it back to you, Devin, because one of the earliest references of trust in technology is Ken Thompson's Turing Award speech in 1984. So Ken Thompson, for people who don't know, co-created Unix, right? And he won the Turing Award in '84. And his I don't remember the exact title of it, but the theme of his speech was the problem with trusting trust. And the essence of it is I can't trust any code that I haven't written myself. So when you talk about DevOps, right? They're the Ricky Bobbies of IT. They just want to go fast, right? They got a cougar sitting next to them, and they want to shake and bake.
If you're not first, you're last.
Yeah, and they don't care about security, and they're not incentivized to care about security. Why should they? It's how many revs of this application can I get out today, right? I mean, it's just at a whole different level. And so,
Absolutely.
yeah, we're never going to solve it by training them to care about that. We're going to solve it by technology that keeps them from damaging us and themselves.
Like a little bubble suit that they put on so they don't hurt themselves. And that's kind of what we're trying to create, actually, is the guardrails and the train tracks. Because when you think about it, like, just American expansionism and the invention of the railroad, the reason that we were able to grow so quickly is everybody agreed on the size of the train tracks. That really hasn't happened in cloud.
Hang on. No. Everybody in this country agreed on the size of the sodding train tracks. Okay. And you changed the bloody things from your damn colonial neighborhoods, which also did something different than half of Europe, which then also did something different than what they did when they went down to the expansion in Africa. And we won't even talk about what the hell they did over in India. Oy vey. I mean, so that's the problem in the analog world. We've all got our sodding fiefdoms or fiefdoms, or whichever way you want to call it. In the digital world, that can't exist, and yet it still does exist, which is a huge amount of the problem that we have to deal with at the moment. So I'm kind of intrigued on this one, and we'll unpack it. Keys, I want your thoughts on this. And then Paul, it looks like you've managed to join us. Welcome. We'll intro you in a second if you don't mind. Keys, give me some thoughts on this one.
Yeah, so when I think of principles of a trusting network, I mean, you really need to start with a very strong single source of user identity, something that really can be owned by the user and controlled by the user. And when you're working through a network or working through a system, you need to have authentication on all fronts. And so when you're talking about zero trust networks, it's putting in those little annoying blockers that say, hey, are you supposed to be here? Are you supposed to authenticate into the next realm or the next level? So having segmented but parallelized environments that can actually handle the load of your employees and your workforce going through, I think are very, very important to building this type of infrastructure. These, let's call it micro containers, if you will, for a zero trust environment. When you talk about trust, trust I would say is you're putting somebody in a position to where you have a very small upside, but a potentially very large downside. In authentication, we really focus on the password side of things. So with a password and a user name that somebody might be using, there's a lot of potential downside to that. You can be phished, there's credential stuffing, there's a lot of things that can go wrong with that. And so when you're talking about a zero trust architecture, it's, what information are you going to trust and how are you going to actually make those stoppers and blockers within the system? And that becomes very, very hard for large systems that want to go fast. Users want to get into the system, they want to start doing their job, and they want to have access to the things that they need. But putting in these railroad blockers and these kind of checkpoints is necessary to maintain a secure architecture for any environment. But there, once again, the small annoyances that people have to deal with.
Well, and to be frank about zero trust, you would never use the word trust positively. You would never say we're creating a trusted system. You're saying we're creating a validated system, or we wouldn't just focus on identity, we would consume identity. Zero trust always starts with what you're trying to protect, right? This is the key tactically to do it, right? Is what do you trying to protect? That's what we were joking earlier on the pre-call. Chris and I are both former QSAs doing PCI, right? And I always tell people I'm a recovering QSA because PCI is a 12-step program. So if you've never read it, there's 12 steps in PCI. So that's kind of the joke for the QSA community. But in that, you learned how to protect one thing, a binary data string called a personal account number. And that's all that mattered, right? Which people didn't understand. I would talk to other QSAs and I would intermediate when I was at Forrester between QSAs and the end user. And somebody would take that and they'd go way out of scope and focus on, here are all the security problems in your entire company. Well, no, that's not your job. Your job is to focus on protecting this one data string. And that one data string has authentication and identity attributes, and it has it should be controlled by layer 7 policy that consumes all that, and it should be monitored and managed and all the logs looked at. And there's a lot of things that happen. So it's an entire ecosystem, but it's about the one thing you're protecting. In this case, it was a cardholder data environment, but it could be anything. And so if we want to really do zero trust, start with the thing you're protecting. Don't trust any packets going to that, and control exactly how access should be done, not just from an identity perspective, but also from a traffic perspective.
Yeah. All right, Paul, welcome. Understood you had connectivity issues, so glad to have you along, sir. Sorry that the morning systems weren't working quite as effective. It's a Monday. I'm blaming, in my neck of the woods, I'm blaming it on snow and sleet. So good to have you along, sir. If you wouldn't mind, please say hi to everybody, introduce yourself, and spend a minute just saying hello. Oh, you're on mute. Just like the keyword for 2020 and 2021 is you're on mute and can you hear me? Those are the two words we're going to remember for this last freaking 18 months worth of COVID.
Exactly. My name is Paul Curylo. I'm currently the CISO for Inova. I've been doing cyber operations now for many years, and been working for the federal government for many more years, doing IC work and lately cyber work. So trust is something of an interesting topic for me personally.
Yeah, we got some good discussions. We actually started it off. We kind of kicked it off with a conversation about, where's everybody's head, where's everybody coming from. So I'm interested on your side of things. I mean, the zero trust idea has been thrown around in various different guises. For us here, I want to kind of unpack the logic on it and then unpack the user and then unpack really the corporate side of it. It's like, how do people do it from a philosophical standpoint? And then also how do they implement it? So I'm kind of intrigued on your thoughts on this.
Yeah, I think about zero trust, and it's it's been used a lot. It's one of those words that has a lot of different definitions, and you use it whenever you want to make a point, I guess. But zero trust is really about being skeptical. What level of skepticism do you start with? And when you start to trust, because at some point you have to trust. When you start to trust, how do you start to trust? What are you gonna hang your hat on? And when are you going to stop trusting? What are the triggers for stopping that trust and taking a step back and revalidating, right? So in my mind, zero trust is just the beginning. It's where you start. At some point, you get to a level of trust and you allow certain things to happen, and then you may gain another level of trust and you may let other things happen. Then you may lose it. So you start to pull back some of that activity. So from a philosophical perspective, that's how I approach it. In practice, obviously, it's a lot harder to implement.
Actually, to that point, I want to unpack that one. JC, we got a couple of questions coming. JC has a really, really good question. I'm intrigued. Devin, I'm going to throw this at you, then Keys, then John, and we'll figure it out from there. I'm going to read the question in the whole, which is, do you think there should be a fundamental difference between human identities, resource identities, and workload identities, or can they be harmonized to use the same logic on it? So how, I guess, in essence, how do we split this idea of what do we trust, where do we trust, and how do we imply trust between, I guess, human, the resources, and the workloads?
Well, let's
Devin,
not use trust as a good thing, right? How do we validate? How do we have confidence, right?
there we go.
Just while you're on the call with me, at least, because I hate the word trust.
All right.
It's a horrible word. So
then I like that because it goes back to what Keys and I we've been talking. I mean, full disclaimer, I'm sitting behind the scenes with those guys trying to keep an eye on various different things. And for me, it comes down to understanding who's on the other end of that keyboard. I just kind of want to know not only who's on the other end, but is it the same identity on the other end of the keyboard? And does it continue to be that same identity on the other end of the keyboard? So I'm interested in that one. Devin, some thoughts on that one between the human side, the resources, and the workload. Do we have to keep them separate, or how can we do them more effectively together? Or what do we do? How do we do this?
It's a great question. I don't know that I have the best answer for the gentleman, but I'll take a crack in it. I think that trust is probably reserved for human relationships. And it's like one of those things where we're trying to codify it and measure it and quantify it and say, oh, it's one thing or another, but it's distinctly a human trait. Like I can trust that humans will act in their own interest. I can trust that I'm going to wake up in the morning and you're all going to have breakfast because you need that. But what I can't trust is a computer. I always go back to Star Wars: A New Hope. They don't let the droids in the bar. Why don't they let the droids in the bar? They don't let the droids in the bar because the droids are monitoring the environment and they don't trust them because they can be corrupted. And that's the state of machines today. And so when I think about trust, the meaningful relationships that I have are the trust. As far as the machine's concerned, it's less than zero for my feelings of trusting it.
That's really interesting. So confession time. I bought a HomePod this last week, and I installed the HomePod at home, and I felt naked. Like, what in the hell's name have I just? I mean, I have taken Alexa literally out to the range, and I have shot Alexa and those stupid little Google Puck things a number of times.
I'll send you my Google Home if you want to make a video of that. I'll send it.
Oh my gosh.
I mean, some other stuff that I can send.
Throw it up in the air and just yell pull, and somebody's going to shoot the ready thing. Yeah, I put the freaking Siri thing in at home.
I bet we get a lot of views for that webinar.
Oh yeah, totally. But it's interesting, the human versus the non. John, give me some thoughts on this one, because this is your baby at the end of the day.
Yeah. I mean, human identity, at the human to human level is distinct. And then when it gets binary, it's the same, right? So I can have identity attributes. I can have a single identity system that thinks of machines and does machine to machine or human to machine, right? Or the asserted identity, because identity is always an assertion. Uh, I, you know, right now it is asserted that John is on a particular computer that is generating packets. So it's now down at the binary TCP/IP level. And so it doesn't really matter whether John is a person, John is a MacBook, or John is a server, or John is a, some cloud instance, which is still a server, by the way. And then, so that doesn't matter. I just need to know some validated identity. That's the who statement. I call this the Kipling method: who, what, when, where, why, and how. Who is accessing a resource via what application, where is it located, when should they be allowed to be on the network, right? Because we should have a lot more time limited rules. And then why is this happening, which is typically compliance or just general security. And then how should we do it? What are the criteria that we build up? Because it's not just a single criteria of identity. So everybody wants to spin zero trust to be identity. And the identity vendors are the worst abusers of the term zero trust. They're making it a plastic word, and I don't like that. So as I said to you, I'm in the battle of the soul for zero trust right now. So the vendors have corrupted what zero trust was meant to be. So 100%. We need identity. What's that?
I'm spot on. Every time I see a zero trust marketing, and this is probably, I think, Chris, what you cued in on my profile, which is everybody's talking about enabling zero trust. How can you enable something that is about disabling? You can't.
Well, you can build zero trust environments, right? But you have to do some research on what it really is. And that's what I'm trying to do is articulate that back again from the original zero trust concepts at Forrester to how do you do it and then how do you manage it. So it's actually simple, right? I've got it down to 9 things. I mean, everybody else makes it complicated. I was just at a thing at the end of 2019. I was at a thing for the U.S. military, and I was showing them how simple it could be. And then I got an email from the officer in charge the next day. As soon as you left, everybody wanted to make it more complicated.
Yeah.
Right. As human beings, we want to make things more complicated, but in reality, simplicity decreases risk. Complexity increases risk. So I need probably the product that Keys has, and I need the product that Devin has if I'm going to build a zero trust environment or help Paul build a zero trust environment at his place. It's going to consume a lot of different resources. There is no magic button that you can push. There's no silver bullet, but it's how those things integrate for the purpose of protecting the things that Paul has deemed are critical in his environment. Those high value assets that if they get compromised, he loses his job. Maybe the CEO loses his job, and customers get hurt, because behind every credit card number, right, there's a human being. And so from the ethical perspective, when people say, "Oh, that was just 4 million records," it doesn't matter. That's too small.
4 million people.
4 million people. You're right on.
And I think that is a huge thing we've forgotten in this industry. And I'm right there with you.
You're not doing this to protect people and make life in general a little bit better, then why are you even in this business? That would be my
that's a whole other webinar that we need to have that conversation. Well, actually,
this is the security over rice bowls webinar.
Yeah, big time. Yeah. Keys,
Johnson, coming off of that point, I would exactly mirror or echo exactly what you said. When you're talking about cryptographic identity, it doesn't matter if you're a human or a machine or a resource. When something's coming over the network, if an attacker gets into your system, into your computer, they can make it look like you. They are the human behind the machine. It's an attack vector that they can then start to move through the system. So cryptographic identity needs to be specific. It needs to be identified on a per machine basis, on a per human basis. And so what we do really well is we build a cryptographic identity on that machine that's not based on biometrics. We're using pseudorandom variables off of that machine, and that becomes their cryptographic identity. So what we're doing is we're taking public keys and we're sending them off to a server, and we're playing a fun cryptographic game with that server. So the goal is that if that server is attacked or that database is leaked, it shouldn't hinder the security. It shouldn't change the security preference. If it was entirely public, it should be completely fine for the user to continue to use their private keys because they're isolated and distributed. That starts to build in a very different type of environment, a very different type of machine logic as well. So when you're talking about a machine-to-machine basis, it's the same things, the same principles that Bitcoin and TLS was built on. You exchange some public keys, maybe you do it 2 or 3 times to make sure you have some secrecy behind that, and then you start transacting. But that trust, and there is no trust. You are getting a statistic metric right now with passphrases and with analytics of, we are 68% confident this is who you are, we're 98% confident this is who you are. We want to remove that analogy entirely. It's you're a 1 or a 0. You're supposed to be there or you're not. And as of right now, digital signatures have provided the platform for us to do that. So when you're talking about validating, a machine or a human, it's all the same. Sign something digitally, make sure it's coming from the right machine, make sure the permissions check out, make sure you have all the right layers baked into that to know where that's coming from.
Yeah, this goes back to, and it's interesting, and we've touched on this a lot, and I'm going to use a good friend of mine, Ryan Cloutier, has an amazing way of putting it, which is analog human in a digital world. And John, you said this a couple of times, and actually, Paul, I want some thoughts from you on this one. We still seem to take a very analog human approach to something that is fundamentally a digital challenge that we're trying to solve.
Yes.
And we have to strip some of this away. Paul, I want some thoughts from you on this one, if you don't mind.
Yeah, anytime you try to represent something digitally, you lose something, right? You don't have that granularity that was once there. You might be able to get the digitization down to a point where it's almost the same, but it's not really going to be the same. So there's that piece of it. But I'll expand on that this way. When it comes to establishing the identity of the other party on the line, say in my network, for instance, it's not an easy thing to do because there are so many different players entering and leaving the environment at any given time. It is really hard to keep track of all of that information, short of collecting all of that information and trying to crunch it at that time. So it gets really hard. So you start to have to rely on signposts, if you will, to really be able to establish whether or not those communications should be occurring or not. And it's exacerbated. The flatter the network is, the more exacerbated that is, right? That's where.
Yeah, it's just almost go back to what John's saying. I mean, again, from the QSA kind of mentality, I've got to look at that data packet. I've got to look at where it's going, what it's influenced, how it's touched, who touched it, when they touched it, are they continuing to touch it, and continue to evolve and make my decisions on that alone. And we don't seem to do that. We seem to have lost that plot somewhere or other.
Well, it gets a little worse because now you need to think about intent and sentiment as well, because that packet might look perfectly okay in the very narrow context that it's viewed in. But you take a bigger context, you look at that in the bigger picture, you realize, oh, there's something else going on here.
So this is where we start. So this is almost the intelligence. I mean, back to threat intelligence and architecture. A single point in time is great, but if I start putting it in context of where it is, what it is, who they're associated with, now you get potentially an entirely different picture.
Well, look at Manning and Snowden, those 2 data breaches, right?
Yeah.
They're on CIPRNet, the world's theoretically most secure network. It's an air-gapped network, and yet, and they were trusted users on trusted devices. They had the right antivirus or whatever their endpoint was. They had the right patch level. They were up to date. They had robust identity systems. They had powerful multi-factor authentication. If you've been inside the U.S. federal government, you know that it's very powerful but hard to use. But no one looked at their packets post-authentication, right? There was no question of who the identity was. These packets are being generated by Manning's computer. These packets are being generated by Snowden's computer, right? But they had access to everything, and no one was looking at what the packet was doing post-authentication. So I was talking to one of the people involved in the Manning thing, and this gentleman said to me, the first time it crossed my desk, I asked, why does a private first class in a forward operating base in Iraq have access to classified State Department materials in Washington, D.C.? And the answer, he laughed, was, of course, because he knew me, a broken trust model, right? So the exploit technique that Manning and Snowden used was trust, right? I say trust is a vulnerability, and it's the only vulnerability that's also an exploit technique at the same time. So you don't have to build new software to exploit trust. You just have to be on the network. You just have to get authenticated, right? And then when you talk about the fungibility of identity, yeah, even if I'm 100% sure that it's John on the network, how do I know that John hasn't, the traditional statecraft or spycraft things haven't been used against John, right? We have threats, we have bribery, we have lots of ways to get people to betray that trust, because betrayal is the other side of the coin. Trust is binary, and the other side of it is betrayal. So, Aldrich Ames and Robert Hansen and all those people were trusted users inside of the FBI or the CIA or whatever, but they still stole things, gave them to our adversaries, and people just let them get away with it because they were trusted and they'd pass polygraphs.
So this is an interesting one, unpacking this. And this, again, Devin, you hit on this one, that, there are unfortunately a number of vendors out there that are waving the cornflake packet of, I can solve your zero trust problem. Yet listening and having these conversations, it's no different than the rest of security. There is no one size fits all. John, you just said it. What you're describing, when you think about it, is user behavior analytics. Take that in the context of what Paul is talking about, user behavior analytics, and building in situational awareness, observe-oriented, side act, threat intelligence, whatever you want to call it. Now I have those two. Right now I've kind of got a better idea and a picture. Devin, take what you're doing and validate that the actual models I'm using have integrity. And then Keys, take what you're using and go, can I even trust the bloody people in the first place? And can I continue to? Now I at least have a fundamental, but it's not a single cornflake packet that says, hey, I've got this whole problem solved. That seems to be fundamentally what we're missing in this bloody industry.
One of the things, Chris, that we're looking at right now, which is a new technology that just is fresh off the press, I guess, is from NVIDIA, and their Morpheus project is super interesting.
Yeah, go for it. Expand on that. Actually, I'm a little bit aware of that.
So, essentially what they're doing is taking a high performance compute and AI inference engines and kind of looking at the needle in a haystack challenge, right? Because we can't possibly understand all these signals, right, on identity. There's just too much noise. But the scale of artificial intelligence and machine learning, we can kind of dissect that information. So we're in the very early stages of evaluating the technology. It looks like it could be used very effectively to sort of parse through these network-based connections, these identity-based connections, perhaps even applying it down to development, source code, dependency trees, and looking at all that holistically and using it to improve the posture, because that's ultimately where we want to go as a company, is creating the framework, creating the train tracks, creating sort of this trusted enclave, or untrusted enclave, right, that we don't trust. Of course. And ultimately, there is, Chris, you had asked about where did I get that 100 billion new lines of code. I believe it was a Cybersecurity Ventures report from the Herjavec group, but I'll go back for some more sources if I need to. But the other component, right, of this explosion of development is a shortfall of security engineers. There's a knowledge base from what we can see, it's at least 4 million. I'm sure it's higher, where we think of sort of our adversaries as hackers, but really they're security developers. They're folks that really understand how systems are designed and work, and how information is processed, and how to exploit that down to the lowest level. So what we're seeing in the industry, Keys, to your point, is we're wherever you store that PKI or that data on that server somewhere, we're looking at all of it and saying, this is Swiss cheese. This server is Swiss cheese. This architecture is we're built on stilts, and that's what we found. There's active 0 days in every single cloud right now from the fallout of the SolarWinds breach. So we wonder, is there not a better way to be building infrastructure?
Let's face it, there's an industry. I'm part of it in some ways on behalf of our friendly folks out of DC. We're actively building the exploits so that we can have that competitive advantage. I mean, we talk about iOS. I mean, take your platform, take your architecture, take whatever you want. The whole idea is to go back to that, whatever it is, 7 to 10 errors per 100 or per 1,000 lines of code. It's like, I got plenty of ways in. I just have to take the time to figure them out. And
that's why, instead of worrying about how you get in, worry about what you're going to protect. People are going to get in, right?
Yeah.
And there's no way to find the needle in the haystack. I mean, you're actually giving people a stack of needles and saying one of those needles is important, but you guys have to figure out the important needle. And that's not a solvable problem. So the solvable problem is I've got a thing I need to protect in Paul's network, right? I have a particular data type or a particular asset. If I'm doing IoT, I'm going to break, instead of saying I'm going to solve this massive problem, I'm going to break it down into little problems and then solve one little problem at a time. And I'm not going to care what gets in. I'm going to care what actually has access to the protect surface, I call it, because I'm inverting the concept of attack surface into protect surface, shrinking the attack surface down orders of magnitude into something small and knowable. And then I'm really worried about what's getting out of that, right?
Yeah.
Because I would argue that the grand strategic objective of cybersecurity, as I've defined it in Zero Trust, is to stop data exfiltration. Right, because
this goes back to this goes back to you'll never stop anybody from getting in. Snowball's chance in hell. Because again, there's so many ways. Now, I want to know as fast as I can who is in, and then I better know what the hell to do about it. That's my biggest thing.
But that's where policy comes in. You know, if we have layer 7 policy, we're going to have a very granular control of that. And so I see that shrunken down 7 to 10 times in terms of policy statement from a traditional architecture and a Zero Trust architecture. So I'm looking at fewer things, right? So instead of saying, you know, there's how many people on the planet, right? I'm going to say there's us, these 5 people, these 5 identities that need to come in and do something in this area. Now that's a much solvable problem, right? And then I can stop Chris from stealing something, because if Chris steals something from Paul's network, right? If that's regulated, if that falls under a compliance objective, it's highly likely that the CEO will get fired. The only thing IT can do to get a CEO fired is to allow a data breach, which is the exfiltration, right? Breach is the exfiltration.
There are temptations on that one.
Yeah.
Writing that down.
But we confuse intrusions versus exfils, right? And so the breach is an exfil. And so target CEO gets fired because IT allows data.
I get where you're going on that. Definitely,
And why hasn't the CEOs of SolarWinds been fired for that?
Instead
of blaming somebody else.
Don't even get me started on that. When they go into RSA, they've been invited to RSA to do a make. Don't even get me started on that one.
So there should be some accountability, because without accountability, there's no incentives
100%.
to do things right.
So that's a very important piece there, the accountability aspect of things. When you're talking about like the internal tradecraft of who's within the network, I think that everybody's really quick to use AI and we've got the greatest neural network that's ever been built. That's awesome, but running it through Occam's razor, there's a simple explanation. It's something that banks have been doing, the military figured out early on. When you join the military and you're a private basic, they give you a battle buddy, because if you are, once again, with somebody, your likelihood of doing something stupid goes down. If you're in a bank and a teller needs to do a transaction, you have a maker checker system. So if you're talking about the internal fraud and the internal environment, it's an easy ask. Randomize it, pick somebody else in the environment and have them look over what you're doing. It's what software engineers do all the time. When you push up code, you have a peer review or a merge request. You're having somebody that is consistently looking at the code and the work that you're doing to make sure that it's valid and agreeable with the entire ecosystem. So it's a very simple explanation to fix and to help mitigate these human problems.
All right,
and just have technology do that.
I'm going to stop for that for a second. There's two questions I want to hit because we've got that 11, 12, 13 minutes, but there's two questions I really want to hit. Paul, I'm going to throw this one at you first, and I don't mean to throw this too heavily, but I'm going to throw this at you first, and I'm going to work at everybody else. Some low-hanging fruit. If I'm sitting there, new leadership, new tech, new whatever, some easy, simple things that I can do to help step us along this path so we can start to implement some of the stuff we've been talking here. Give me a couple of thoughts if you don't mind. I'll ask everybody else briefly as well.
Well, okay, so start with understanding what it is you're trying to protect, because you can't protect everything. And then for those things that you absolutely have to protect, start getting some barriers in place that make it more expensive for somebody who wants to take it in an unauthorized fashion to do so. That could be, implement MFA, that could be segmentation, whatever it is. Just make it more expensive for somebody who you don't want to have it to get it. So those, I would start with those two things because there's plenty to do in those two places.
Perfect, and I love you for that one. Keys, thoughts on that one to add on to that, or just a yay for whatever?
I would say add on to that. So once again, find out what you need to protect, find out where the critical infrastructure is, and then build a wall around it. Defense in depth. How many layers do you need to get to until you get into this protected space?
You mean I can't buy my cornflake packet of zero trust and hope for the best?
No.
Shattered my dreams today, which I'm actually really happy about. Devin, thoughts on that one?
Practice how you play. Principle of least privilege in your development environment and your production environment.
All right, so let me unpack that for 30 seconds. We had a little bit of conversation about DevOps and the challenges around that one. A lot of us in the industry are trying to go back to the development teams and the operations teams with the whole idea of DevSecOps and going, hey, sorry, we screwed up. Not only did you screw up, by the way, we kind of blamed you for everything at the same time. We still kind of blame you a little bit, but we'd like to be friends at the same time. I'm doing what I can to help on. Give me your thoughts on that one. How useful is that?
DevSecOps as a methodology, or
yeah.
I think it's an intermediary state. I believe it's the bridge to try to get security and development to work together, and it's a cool term, and it makes a lot of sense to some people. I think the DoD has really grabbed onto it as a way to go about developing their next generation systems. But I think that I guess ultimately it's about education, right? And really just understanding the fundamentals of development. I'm not a developer myself, but I'm a generalist, and I focus on the customer conversations that we've had. The biggest challenge is developers who really like doing it their way, and they're very talented. There's so many, they're maybe the best developer there, but they have a way of doing things that doesn't necessarily work. And so companies are concerned about losing that talent, and they don't want to make wholesale changes to those environments when there's so much at risk, which is their profit stream. So you're not gonna, there's no company in history that ever just killed itself just for the sake of innovation.
Awesome. John, sir, back to the, give me some, we've had Paul, Keys, Devin, some pretty awesome thoughts for people like, I'm at zero. I don't know where to start with this. Thoughts on building?
So there's two things that I created. One was a 5-step methodology. Start with defining your protect surface. What do you need to protect? Second, map your transaction flows. How does the system work? If you don't know how the system works, you will never protect it. Third, then architect it based upon the thing you're trying to protect. Fourth is create policy so that you have a very granular policy statement. That's called a Kipling method policy. And fifth is monitor and maintain so that you can re-inject what you've learned through log files and threat and stuff, and create an anti-fragile system. If you're a fan of Taleb and you've read Anti-Fragile, Zero Trust is an anti-fragile system. That's the first thing. And then there's a second thing I created, which is the Zero Trust learning curve, where you start small and you do this in bite-sized chunks. So you do some learning protect surfaces which have low sensitivity or low criticality first, so you can learn how to do it. Then you do some practice protect surfaces. They have a little more criticality, but they're not the crown jewels. So you get to Zero Trust the same way you get to Carnegie Hall. Practice, practice, practice. And once you've figured that out, you will then be able to take care of the crown jewels, the keys to the kingdom, the high value assets, whatever you call it in your organization, and you will know how to do it. And then every other protect surface will be deployed in that same way. So those two resources, the 5 steps model and the learning curve, are what I point everybody to begin their zero trust journey. And it is a journey.
All right, so I'm going to add on to this one, and again, we're running low, which is one of the questions that came in midpoint that I promised I would ask. We've barely scratched the surface on this. I really want to keep this. Actually, what I'd love to do is do this with like the ITSP folks and have some fun with those guys and really kind of cause a bit of chaos in this world. Don't be surprised if I reach out and we have these conversations again. Give me some further reading, some thoughts, because again, we've barely scratched the surface of this. I think we've unpacked that it's not a single cornflake packet of a solution. So any vendor that comes in and does that, if you don't have a taser, I'll send you one. You're welcome to use the damn thing. Video it, put it up on YouTube, it'll get likes. But my big thing on this one is I want some further reading, some further thoughts from each of you. How can everybody get hold of each one of you? Can they ask you questions? And then what do you recommend that they do for some thoughts go forward? Again, I'm going to go back to Paul, if you don't mind. I'll start off with you. I'm starting that way and we're working that way, like a reverse typewriter.
Oh gosh, where to get started? There's a lot of different ways to get started. I would say just get started. This is not a thing where you're going to do a lot of research ahead of time. You're going to have the luxury of time to figure it all out and then get started. So honestly, don't wait to get started. Start consuming material, start understanding the problem set that you're dealing with, and start to line up for quick wins, some of that low-hanging fruit. I don't really have any specific, no single, start here panacea and you're going to get to the right place, because so many of our environments are different. Just simply get started and have dialogue like this. This helps.
I think you're right. And I mean, I'm going to add on to what you said earlier, which is the understand what you have. I mean, I think everybody said it, which is, know yourself. So many organizations, and we've seen this, I'll put the Signet hat on for a second. We've seen this too often where we've walked in and companies don't understand what assets they have, let alone what's on their network, let alone they don't have in their own eyes, they don't have enough hands or eyes on their network to understand what to do with it. And to me, that's a basic fundamental, situational awareness. We've is drilled into us from the military. You try not to go charging through the door until you actually know what the hell's about to hit you in the back of the head. So to me, it's no different. So I think I would argue you've got a bunch on there just from your experience, the knowledge you have on this one. Keys, give me some thoughts, please, on your side of this.
Yeah, I would say, what's the difference between a dream and a goal? If you dream of, moving to a zero trust architecture, put a deadline behind it, put a timeline, put a map. So, hey, this is where we are. This is where we're starting today. Understand your system, but understand where you want to go and define that. Put that down on paper, write it down. Are you building, access control engines? Are you building a security policy team? What are the steps that you need to get to that endpoint? And then start putting those actions in place. And by doing so, you will eventually get to where you need to go, just one step at a time. I'd say, go ahead.
No, is this something where like the NIST stuff comes in, or something where like that whole framework? Nope. All right, John, we'll get to you in a second on this one. I'm really intrigued. Yeah. Go for it, Keith. Sorry, I apologize.
Oh, yeah. So if you're looking for a good book to read, I would recommend Life After Google. Just some good principles on how you're building things, what type of technology is coming out, how to implement those. Looking at the environment that you're in, and you're going to get a lot of vendors that are going to be asking for a lot of different things. But asking yourself and running it through Occam's razor, does it really fit the problem that I'm trying to solve? Is it really going to help me get to my end goal, or is this just extra fluff and extra cool sales stuff that they're selling me? Is there an actual benefit to your system, and does it apply to your system? So those are the things that I think really matter.
All right, Devin, give me some thoughts though.
I painfully quick skimmed the zero trust architecture this morning before the call. I thought we were going to talk about it. Thank God we didn't. It's interesting. One of the things they say is that implementing a new zero trust technology refresh is not going to create zero trust for you. The other thing that is interesting is that they kind of allude to it's easier to do this in a greenfield. So I'm excited about startups that are trying to solve real big problems right now and want to kind of go greenfield on this. But you know, in terms of where we go from here, I think that if folks want to reach me, I think because that's what you asked, Chris, Devin at CHAaSM, and we'll take a conversation you know, about the kind of challenges you're facing. But we're really focused on development-centric organizations, producers of IT, right, versus consumers of IT. So we want to differentiate that and focus sort of at the bottom, which for us is the source code and the dependency chain.
All right, cool. Question, John, as I hit you, question came in, is there a link to John's 5-step process? So let's ask that one, and then let's get into the...
Yeah. So I sent you an email because I couldn't figure out how to use add in GoToWebinar, a link to the Zero Trust terminology page at Palo Alto Networks, because all the stuff that I did is still on Palo Alto Networks website. But that's the best place to start, because I did that in a vendor neutral way for the US federal government. So they would have a specific dictionary, what is the real terms? And it has links, I think, to a lot of those things. But the 5-step report is, it's on Palo Alto Networks website. And if anybody wants it, I can get it for them. But I mean, you look at, like you asked about NIST. I don't know what NIST 800-207 is, but it's not Zero Trust. It's actually about a way to do identity that may not be the best way to do identity.
Yeah, it's
ultimately,
yeah. Not sure. No, I wasn't going on that one. I was like 853, 171, at least.
Okay, well, but what's happening is that NIST has just become a marketing arm for big business who have enough lobbyists to influence them.
Oh, I'm going to defend them. We'll have to unpack this a bit more. I'm actually going to defend them.
But 800-207 is sort of a disaster from my perspective. So.
Can't disagree. Yeah.
Yeah. So, you know, but I guess they're trying to do what they can.
Well, here's why. Can I read you something from that, John, real quick? Because I have it in front of me. Here's a great example of a disaster. For performance and ease of management, the application hosted in cloud provider A should be able to connect directly to the data source hosted in cloud provider B, rather than forcing the application to tunnel back through the enterprise network. So I'll just
let's not do that, please.
Well, you know, so
I mean, it hasn't been updated since August.
Yeah, that's another webinar, Chris. But the reality is, Zero Trust is a strategy designed to resonate to the highest levels of an organization, yet be tactically implementable with whatever technology is available at the time. The strategy is decoupled from the technology, so there are no Zero Trust products. It's not about identity. It's not complicated, but you have to look at it strategically. So, you know, create a Zero Trust Center for Excellence. Get people talking about it. Start somewhere. It doesn't really matter where you start, but start by thinking about what you need to protect. That's what everybody misses. Because everybody's trying to position their product. I have this widget. You need this widget. I have this piece of the puzzle. You need this. I don't know how would you ever know until you know what you're going to protect? That's the problem. You can never know what pieces of the puzzle you need because you don't know what the puzzle is supposed to show, right? So you're just randomly putting things there, and you don't even have the box cover to look at what the picture is supposed to be.
Yeah. I really want to keep this going for like another hour, but I also want to be respectful of everybody's time and the fact we've got folks on the audience and the fact that Gabrielle's probably going to yell at me if we keep this bloody thing going forever and a day. Absolute freaking pleasure. Like, seriously geeked out on this one. Really, really appreciative. John, Devin, Keys, Paul, heartfelt thanks on this one. And as always on this one, to Gabrielle and the Wiser crew for putting this on and for letting us kind of geek out for the last hour or so. Huge thanks to all the questions. I think we hit a bunch of them, but there's probably a bunch more that we can go to. Yes, it's recorded. Yes, it'll be up on the Wiser website. Guys, much, much appreciated. I kind of want to do this again. Let's stay in touch and try and kind of geek out on this one again somewhere at some point. Stay safe, stay healthy. You guys know the idea, and thank you very, very much, everybody.